In this video, we'll learn about registers in assembly. Now, it's really important to learn about the basics of assembly, and what registers are basically are just variables, right? We're tiny, not exactly variables that you know from other languages, but variables that, in a sense, that these are just tiny boxes where you can put your data in or addresses in. So in this video, we'll talk about registers and the types of registers and what purpose do they serve. And I just thought that it would be important to talk about these in the beginning so that there's no confusion later on. Now, the first type of registers are the general purpose registers. These are called general purpose because they are basically for everything, and we'll be using them a lot. So what's the first register? We have used it already in our last video, which is the AX register. It is also called the accumulator register. Thus, the name AX. At least that's what I think. Now, AX register is used for arithmetic operations. If we remember from, or the input output, as we know from our last video, we were calling BIOS interrupts by using the int 10h, right? We are using the high byte of AX register, which we will be discussing what is high byte and what is low byte of a register. So we were using the high byte AH of the AX register, right? So this is really for arithmetic and input out. Now the other register that comes under general purpose register is the base register. Now base register is often used as a pointer to data in memory. So what do I mean by that? If you have programmed in any language, or well, moreover in C++, then you have used pointers. Now, if you haven't, then you can go watch a video on it. But what are pointers? Pointers just point towards an address in your memory. Now, in assembly, BX is often used as a pointer to some data. So it's not really storing that data, but it's rather pointing to the address of that data. So that's what BX register is basically used for. We will look more into it as the videos move on and we move on to advanced concepts like subroutines and all kinds of stuff. The CX register is the loop register. It functions like a loop because when we are doing some increment, we are using CX register, it just decrements itself when we're using loops. And we will look into that as well. So CX is basically doing that purpose, and we will if even if it's a common practice, even if we decrement it, even if we want a counter register ourselves, we'll mostly use CX register and we'll just manually decrement it, or otherwise we'll have other way in which the CPU decreases the CX register on its own as well. The DX register is the data register. Now, it's used in multiplication and division, and basically for input-output port addressing. Now, what's port addressing? Port addressing is basically when we're accessing our keyboard and mouse and our peripheral devices. The next kind of registers are the index registers and the pointer registers. Now, these index registers, the first one in that is the source index register. Now, these registers have special jobs. So the source index register is used as a pointer for source data in our string operations. The DI register is the destination index register. It's used as a pointer for destinations in our string operations. We will look more into it. It's a bit of a complex thing, but we will look into it in our next video. But the next one is the pointer register, which is a base pointer register. Now, by the name base, it basically points to the start of our stack, which we have in assembly, which we will use when we are using calling functions, or in assembly we call them subroutines and not functions, which are basically functions, but basically functions, not exactly functions. Now, we also have the stack pointer register, which points to the very top of the stack. So base pointer to the start of the stack, which is the bottom, and stack pointer, which is top of the stack. Now, the stack pointer register, we don't really use it for anything, but it's basically manually handled by our CPU. It would do it on its own as we're pushing and pulling data, pushing and popping data in our stack. It would just manually update. The next kind of registers are the segment registers. Now, since we're using DOSBox and we have the .com file, where we also wrote org100h, which means our first 256 bytes are reserved for the .com file. So we're using the DOSBox format, right? That means that the CPU can only use 64 kilobytes of at a time via a segment. So we'll use 64 kilobytes of segments to talk to our CPU, basically. In segment registers, we have the code segment register, where we have the executable instructions that live. So any kind of uh, operations and logical operations that we're doing, we'll be doing in the code segment. We also have the data segment, where our variables and constants are stored. So we're, for example, we're storing an array. Yeah, yes, we do have an array in assembly. It's not exactly an array, but let's say we're storing any kind of variable, any kind of data in our uh, assembly, then we'll use the data segment. It's a separate segment from the code segment where we are doing logical operations. Now, the stack segment is another segment where the stack lives, which we already discussed. We also have another segment which is called the extra segment. It's basically an extra pointer, often used for video memory, or what we were using in the last video as well, the VGA mode. And we will discuss more about this extra segment, and we will have to use it in our future videos. We also have something called the special registers. Now, these are very important. So the first one would be the instruction pointer register. Uh, we cannot directly move data into instruction pointer register. It basically holds the memory address of the next instruction that will be executed. So it will be pointing towards that next instruction, so that after CPU is done executing the previous one, it can basically automatically move to the next one. We also have flags. Now, flags is a big topic, and it has a lot of complexities and a lot of things. It's not really that complex. When I was in university, I had some problems with it, but in reality, it's not really that complex. We would talk about it a little bit in this video. So, what are flags? They aren't for storing, let's say they're not for storing numbers, they are for storing states. Now, what do I mean by states? So if we compare two numbers in Python, or if we compare two numbers in other languages like JavaScript or any kind of other language, high-level language that we use these days, we use the comparison operator, like greater than equal to, less than equal to, greater than, not equal to, right? How do we do that in assembly? Well, to do that in assembly, we have to use flags. So for example, we have a zero flag. So let's say we compare two numbers, let's say 2 and 1, and we are using the CMP operation to compare these two numbers. Now, if those two numbers are equal, then the zero flag will turn on. Why it will turn on? Because when we're using the comparison operation, then basically what it does, it just subtract the two numbers, and it checks if the result is a negative or it's positive. If it's negative, then basically that means they're not equal. If it's zero, then the zero flag would turn on, and we would have the zero flag turned on. There are other kinds of flags as well that we will discuss in our future video. We have the carry flag. Uh, there are the overflow flag, a bit complex, but we will discuss it when we will be using them. Now, these registers, the general purpose registers, they divide. As we discussed, the AH is the low byte, the high byte, I'm sorry, the high byte of the AX register, and the AL is the low byte of the AX register. Now, what I mean by high byte and low byte, so AH being the leftmost 8 bits in our AX register. We know that our AX register is a 16-bit register. So the AH in is are the high bytes or the leftmost, the most significant high 8 bits of our AX register, and the AL register are the least significant bytes or the low bytes of our AX register. That's basically what they are. Sometimes we don't need to use the entire AX register for doing something that can be done using AH and AL, and we have used AH to call uh, input output operations in the last video when we were calling the CPU to we were using the interrupts. We did use the AH register. Now, in the next video, we will be doing our first animation. My goal for this series, for the next 2 videos, is to basically be able to create animations and then create character and being able to control it using our keyboard. So, if you are interested in that, stay tuned for that.